each step. So let's start by listing out what those algebraic properties of equality are. First of all, we have addition and subtraction. So we have the addition property and the subtraction property. The addition property simply says if A equals B, so if I have some equivalent statement, then I can add some number C to A, and it will be the same thing as adding that same number C to B. That's the addition property. The subtraction property, you know, is basically the exact same thing. The subtraction property just says if A equals B, then I can also subtract some number or quantity from A, and it will be the same thing as subtracting that same number or quantity from B. So A minus C equals B minus C. All right, then we've got the multiplication and division properties. So multiplication, and I'm going to stop writing the word property because they're all properties, but I just don't feel like writing the word property. So if A equals B, then the multiplication property says I can multiply A by some other number or quantity C, and that's the same thing as multiplying the right side, or B, by the same number or quantity C. So AB equals B, or AC equals BC. Okay, so then we have division. The division property of equality states if A equals B, then I can divide A by C, and it's the same thing as dividing B by C. However, I'm going to put in parentheses, you need to make sure that you're not dividing by 0. So C cannot equal 0, because then it would be undefined. And then we do have one more property of equality, and that is the substitution property. And you're going to see this used as a reason a lot when we start writing proofs. So the substitution property of equality simply states if two things are equal, so if A and B are equal, then you can substitute or replace A for B and vice versa in any equation. That's what the substitution property says. Alright, so those are all the properties of equality that we're going to be looking at today. Let's do our first example. We have the equation 2x plus 5 equals 20 minus 3x. So the goal is to write a reason for each algebraic step of solving this equation. First of all, looking at just the equation, you know what to do first, okay? You would want to get the x's together, right, on one side, and then get all the non-x values, or all the constants, together on the other side. So the first thing you might think to do is maybe add that 3x to both sides, right? You might think to do that. And you don't have to write this just yet. I'm just describing what your thought process is. Well, we would need a reason for why we're allowed to do that. And that reason is just the addition property of equality. So that's kind of where we're going with this. So let's write this out kind of like a proof. So the first reason that I wrote the equation was, well, simply that was given. That's what I was told to do. So that is legitimately a reason. You would write given. The explanation for what I'm doing right there is I'm just writing the original equation. Seems a little obvious or redundant, but just so you can kind of see what I'm doing. So that would be my first step, quote unquote. So the next thing I want to do, as I mentioned before, is I'm going to add 3x to both sides of the equal sign. And so what I'm doing there is I am adding 3x to both sides. And so what I said was the reason behind this is now we have a property called the addition property of equality. I'm going to write prop of equality. So I'm just abbreviating. Addition property of equality. So let's keep going. When we simplify this, 2x plus 3x on the left-hand side is 5x. Plus 5 equals, now we're just left with 20 on the right-hand side. So what I just did there, explanation, was I combined like terms. Now you won't have to always write this explanation part. You're just going to have to write the reason, what I wrote in light blue on the right. That's what you're responsible for writing. I'm just giving you an explanation of what I'm doing. So here I'm combining like terms. My reason is just, I'm simplifying. So it's not an actual property of equality, but this is a fair reason. I'm just simplifying. Alright, the next step, you want to subtract that 5. So, if I'm subtracting the 5 from both sides, hopefully you see that I just get 5x is equal to 15. So what did I do there? What happened? I just subtracted 5 from both sides. Okay, and what's my justification or my reason why I'm allowed to do that? Well, that is just the subtraction property of equality. So this is the reason you would have to provide. Subtraction property of equality. And finally, the answer to this problem, you would find it by dividing both sides by 5. So when you divide both sides by 5, your final answer is 3. What did I do there? I simply divided both sides by 5. And the reason or justification why I'm allowed to do that is there is a division property of equality that allows me to do that. Awesome. So that was your first example. You would be responsible for writing out any reasons for each step. So everything that I wrote here in the light blue, you need to get familiar with writing. Okay, cool. So also, we're going to be using the distributive property in algebra. So that is another reason you can use. Even though it's not one of the properties we just listed today, hopefully you've heard of the distributive property. So let's go ahead and work out this next example. I'm going to ask that you actually pause the video for a minute, try to solve this algebra problem on your own, and see if you can provide a reason for each step on your own. But I am going to work it out now. So obviously we're going to rewrite the original equation, and that reason, as I said before, is just given. That's what we write when something's given to us. The next step to this equation is just distributing the negative 4 through, or multiplying. So the result would be negative 44 x minus 8 equals 80. The next step to this algebra problem comes from adding the 8 to both sides, and this is by the addition property of equality, and I'm just going to shorthand that and write addition. So when I add the 8 to both sides, the next step should just look like this. Okay, finally we're going to divide by negative 44, and we're allowed to do that by the division property of equality. That's our reason. And when I do the division, the next step is just the answer. We get x is equal to negative 2. Okay, cool. Alright, the next example I'm going to show you is a little bit different. I want you to just take this formula, which is the formula of what? Area of a triangle. So this is the formula for area of a triangle, and I want you to just see if you can solve this for B. So there's no numbers involved really. You're not solving for B per se given a specific area. You're just literally rewriting B in terms of A and H. So I want to see if you can do this on your own if you pause the video. I'm going to give you the solutions though in a moment. So pause it, see if you can work it out, and write a reason for each step. So here's the solution to that. The last thing I want to do here is just give you a different example of using these justifications or different justifications that we've learned about this year to show something. So this is what a proof is going to be that we'll talk about next week. We want to show something is true. So given this picture, I want to show that AC, or the length of AC, is equal to the length of BD. That's what we're going to try to show or prove or justify. So let me work this one out for you. Given the equation, the length of AB is equal to the length of CD, I'm going to start there. So that is my given information. So my reason for writing that first statement is just given. The next thing that I can write here is that segment AC, which is this segment right here that I'm highlighting, is equal to the length of AB plus the length of BC. Now, why can I say that? Why do you know that? Think about it. The reason is you learned about segment addition. That's the segment addition postulate. So the segment addition postulate. And by the same exact reason, by the segment addition postulate again, this is not letting me scroll down. I don't know what the heck's going on. There we go. By the segment addition postulate again, so I'm going to write that as my third reason, segment addition postulate. What else can you say about this picture? Which other two segments added up will equal a longer segment? So if you take a look at the original picture, that would be BD. BD is formed by adding BC plus CD. So far we've provided 3 reasons for just giving you some information that will lead us to showing that AC is actually equal to BD. So let's try and finish this off with another statement. I can say that AB plus BC is equal to CD plus BC, and the reason for that is simply the addition property of equality. Just like when you're adding numbers to both sides of an algebraic equation, I can add BC to both sides of this given equation by the addition property of equality. So then notice you can actually replace what you wrote in these last statements. You can replace what you wrote here in this new equation. So we're going to be using the substitution property. The hint was I said the word replace. The substitution property to say that AC is in fact equal to BD, which is what we were trying to show. So what did I replace there? Well, look at what I have written. AB plus BC. That was simply AC. CD plus BC was simply BD. So now that we've linked those two things and substituted them, we can say that they're equal, which was what we were trying to show. Okay, I'm going to leave you guys with this exercise. Try to fill out the missing reasons for each step of this algebraic equation. I hope you enjoyed the video. I will see you tomorrow.